In this unit, we'll introduce the concept of binary representation of information. So computers are binary machines, and this just basically means that they only have two possible states in their circuits. So we can consider the information in the computer like a collection of microscopic switches that can be on or off. And actually at the beginning they were not microscopic at all. Here in this picture on the slide you can see under the memory card a part of the RAM memory of the computer that used magnetic rings. So representation of information is done through a digit that can take two possible values, 0 or 1. And that's a bit, a binary digit. With a sequence of bits, the computer can represent anything. Numbers, letters, pictures, sounds, instruction of a computer program, and any other data is represented by a bit. So let's look at an example. You might remember Paul Revere's lantern to alert about the British troops. So what was done in this, what Paul Revere did, was the one lantern meant that the enemy was going to arrive by land, and 2 meant that they were going to arrive by sea. And this is a binary decision. So we could represent this with bits. We can use 2 bits to represent each of the lanterns. And therefore it means that if one lantern is switched on, somebody is approaching by land, and if the other is also turned on, they're approaching by sea. Therefore we need 2 bits to represent this decision. And we can include more alternatives if you want by just adding more bits. So bits are usually grouped in blocks of 8 bits, and 8 bits is called a byte. And nowadays end users do not really need to manipulate individual bits, but it used to be a very typical interface to the first computers, as you can see here on the slide. So we have seen a little bit the binary representation of information with bits that are 0 and 1.